Today we're in section 4.3, equivalent fractions on page 182. Page 182. All right, so in example 1, we're writing fractions that are equivalent to a given fraction. All right, so there's just a couple things that I need you to show on problems like this. First of all, we always start with the original problem. Then I need you to show me what you're multiplying or dividing by to create an equivalent fraction. Now with these guys, there's literally like 1,000 different ways that you could write the correct answer. So showing your work is important because I don't want to have to guess at what you're multiplying and dividing by. All right, so if we want to divide, what number could we divide by? 8/12. I could divide by 2 to get 4/6. Okay, and now I've written an equivalent fraction. All right, what's another way? I could divide by 4. Very good. And that would be 2/3. I could also, now that's my two equivalent fractions. On your homework, your quiz, your test, you'll be asked to write two equivalent fractions. So technically, we could be done right now. Now let's do a couple more just to kind of give you an idea of just the different options we have. Now notice that for each equivalent fraction I'm writing, I'm rewriting the original fraction. I'm not working off of another equivalent fraction. Does that make sense? I'm always using my original fraction. I can multiply this, and the possibilities are endless. I can multiply by 2, I can multiply by 3, I can multiply by 5, I can multiply by 1,000, okay? I could literally multiply by whatever number I wanted as long as I multiplied top and bottom by the same number. So let's just do 2. And guys, you understand when I'm writing 2, I really mean 2 over 2. Right? Okay. You guys understand that? I mean, I really don't care either way that you write it as long as you're just showing me what you're multiplying by. All right, and then you get 16/24. So that's another way that you could write an equivalent fraction. Let's do 4/16. Can I reduce it?
Yes.
By what?
4.
I can reduce it by 4. Okay. Which gives me 1/4. All right, so there I have one equivalent fraction. But, again, my instructions say 2 equivalent fractions. So I need to rewrite my original fraction, and now you can multiply this one. Or could you divide by a different number?
Yes.
What could you divide by?
2.
2, very good. Okay, so divide by 2/2. And if these were the fractions you wrote, that would be perfectly fine. Now, if you decided for 4/16 that you wanted to multiply by 2 to get 8/32, that's perfectly fine too. Okay, and then if you multiply, the possibilities are endless. You can multiply by whatever number you wanted. And as long as you show, guys, this is the important part. You must show me what you're multiplying and dividing by. And you must use the original fraction, okay? So these might be easy, but I'm going to get you on the work, okay? So please make sure you show all of your work to get full credit for these questions. Got them? Okay, so what for 9/12, what could I multiply or divide by? Somebody give me some suggestions. Mason? Okay, divide by 3. Very good. Divide top and bottom by 3, and I get 3/4. That's definitely one way. Grayson? What's another way?
You could multiply.
Multiply by what?
50.
Okay, 50. All right, so if I multiply top and bottom by 50, I get 450 over 600. Hey, that's an equivalent fraction. All right, what's another number I can multiply by, Colin?
1 million.
1 million. Okay, all right, guys, come on. All right, now listen. Now here's the thing. If you want to do 1 million, perfectly fine, but just realize the more complicated you make the numbers, the more chance you have to make a mistake. I stick with 2, 3, and 4 if it was me. I mean, I'd stick with the basic numbers. There's no sense in getting creative when you don't have to. All right, but whatever you chose, as long as you show me what you multiply or divide by and you box your answer, use your original fraction, you're good to go. Writing a fraction in simplest form. Okay, now I am not necessarily concerned on this example. Okay, now with equivalent fractions, because there are so many options, I need to see your work. I need to see what you're multiplying and dividing by. With reducing, I don't mind if you just go ahead and kind of reduce using mental math. What are some common factors that can go into 12 and 30? Amelia? Okay, 6. Now, what are some other factors? 3 and 2. Now, 6 is the biggest one, and if you can start with 6, you'll only have to reduce once. Let's say you reduce by 3 and you end up with 4/10. Is that your final answer? No. So if you don't get the biggest number, or what we call the GCF to start with, you're going to have to reduce twice. I don't mind if you reduce twice. I'm not going to count off for that, as long as your final answer is in simplest form. Okay, so now let's look at 8/12. What can I reduce 8/12 to?
2/3. 4.
By 4, very good, to 2/3. All right, try the last one on your own. Contiguous. Okay. All right, so 15 over 21 reduces to 5/7. Okay. All right, any questions about reducing fractions? All right, so now let's look at a word problem. It says it's a geography problem. Basically, it says that your textbook shows 48 contiguous states in the United States. Of the 48 contiguous states, 21 are coastal. Write the fraction in simplest form of contiguous states to coastal states. So how many total are there? How many total states? 48. And how many of them were coastal? And then we're just reducing the fraction. Okay, it's one of the simpler word problems, especially given the word problem you just solved on your test. All right, so 21 over 48, I'm going to reduce, what can I reduce it by?
3.
I can reduce it by 3, very good. And if I reduce by 3, I end up with 7/16. And that's going to be my answer. All right, so now, okay, you know how to simplify. Now let's work some variable expressions. We're simplifying variable expressions. This is by far the most important part of the lesson, so you really need to pay attention to this example. This is what you would probably see the most of on a quiz or a test from this section, is simplifying a variable expression. Now I'm going to write these a little bigger. 10xy over 15y squared. All right, now the first thing I want to do when I'm simplifying a variable expression is I want to simplify the number part of the fraction. So 10/15 can reduce to what?
2/3.
By 5 to 2/3. Very good. Okay, so I have 2/3. Now I know that, okay, so I've got the y left up here. And I know that y squared is the same as what? Oh, I'm sorry. I got my egg still. 2xy. Now, what is y squared? Y squared is the same as y times y. Okay? Don't put y, put y times y. Okay? And here's what I want you to see. Now, I'm going to show you a shorter way of doing this, but I want you to see it broken down first. All right? I've already simplified the number part, and I can also cancel out any common variables in the top and bottom. Okay, so since I had 2 y's there, I can actually cancel them out. So my final answer would be 2x over 3y. Okay, because the y is canceled. There was one y that was common in top and bottom, so I could reduce that. Okay, to cancel them out, and I'm just left with 2x over 3y. All right, now let's look at the next one. I have 15. I just want you to see how it's broken down. Do you see how y squared is the same thing as y times y? Okay, so I want you to picture that when you're writing these expressions. 15x squared y to the third divided by 30x. Okay, so how can I reduce 15 over 30?
Put 5 in both of them.
Okay, put 5 into both of them, or 15 into both of them, and what does it reduce to? 1/2. All right, so now look at your x's. You know that the x on the bottom has an understood exponent of what?
1.
1. So technically, does everybody agree I have 2 x's on top and 1 on the bottom? Everybody agree? So if one of the x's cancel, wherever guys, listen to what I'm saying. Wherever your largest exponent is, that's where your leftovers are going to stay. So since 2 minus 1 is 1, and since your larger exponent is on top, your x stays in the numerator. Now, if that went over your head, that's okay. We're about to do several examples, so just stay with me. Now, with your y's, were there any y's on the bottom?
No.
So I'm just going to be left with y to the 3rd on top. All right, now I have one more question for you. Technically, do I need to have this 1 up here in front of the variables? Because it's understood, I do not have to have it. Now, what if you didn't have the variables? Could you just have a blank numerator? No, then the 1 would be necessary. So if you keep the 1, that would be fine. I'm not going to count off. If you leave the 1 off and you say xy to the 3rd over 2, that is the more accurate answer for this expression to be reduced. Okay, so 16 over 40 reduces to what? 2/5. Very good. Okay, so I have 2/5, and then I have a on top and a squared on the bottom. So I know that one of my a's can cancel, and where do I leave my leftover a? On the bottom, and why? Because 2 is the larger exponent, so I leave my leftover where the larger exponent was. All right, and then what about my b?
It goes on the top.
It goes on the top because that's where my larger exponent was. 2b over 5a. Who got it right? Awesome, guys. Good job. All right, very good. Any questions on solving variable expressions? You have a section like this on your homework. Okay, one more example. One more example. You're going to have a section on your homework that asks if the fractions are equivalent. Okay, and this is what it means. If I had, let's say, 3/4 and 4/16, and I said, are these fractions equivalent? Well, you know, you can't tell me right now because right now they're different fractions. What you have to do first is you have to make sure that they're both in simplest form. Can I reduce one of them?
Yes.
4/16 reduces to what?
1/4.
Is 3/4 the same thing as 1/4?
No.
So I would say no. Okay, and here's what I need. I need both fractions in simplest form, and then you say no. If all you say is yes or no, I'm going to mark it wrong. You have to show me both fractions in simplest form. All right, so now I want you to do this one. What if you had 12 over 15 and 26 over 30? Okay, so write them in simplest form and then tell me whether they're equivalent. All right, so 12/15 reduces to what?
3/5.
4/5. 4/5, very good. And then 26 over 30 reduces to
13/15.
13/15. So are they equal?
No.
No. Now, if they end up being the same exact fraction, then you would say yes. All right, so you just have a couple of those on your homework tonight. You might see that on a quiz or a test. But if you understand that, that's everything you need to know for 4.3.